Scale diagrams and scale factors and scales can be a little bit confusing at first, so let's see if we can sort them out. The idea behind a scale diagram is that you have a diagram that is either much smaller than the real object or in some cases much larger than the real object. And sometimes the real object is an image or a diagram itself, so you just simply have a smaller version of the image, which would be a reduction, or a larger version of the image, which would be an enlargement. And we do that sort of thing on the photocopier all the time. So on the right here I have a scale diagram of a car. Obviously it's a lot smaller than the real object, and we need to know, in real life how long this car is, and on the diagram how long the car is, in order to figure out the scale factor for this particular diagram. So in real life, the car's length, let's say, is 480 centimeters. So the length is 480 centimeters. Now, on the actual diagram, on my computer anyway, it looks like it's about 8 centimeters long. So in order to calculate the scale factor, you simply take the length on the image and divide it by the length in real life. So for this particular one, we have length on the image is 8 centimeters, and the length in real life is 480 centimeters. Now, it's very important to make sure that the units are the same. If instead we were told that the car's length was 4.8 meters, the first thing we'd want to do is convert that into the same unit that we used to measure the length in the diagram. So we'd convert that to 480 centimeters. So 8 centimeters over 480 centimeters. The centimeters cancel out and the scale factor becomes unitless. That's quite important. There's never any unit associated with a scale factor. Now, there's a lot of different ways to write scale factors and scales, which are essentially the same thing, but the different ways you'll see in different contexts. One way is just simply to divide 8 by 480 and write it as a decimal. And you would get, in this case, 0.016, but the 6 is repeating. So this is convenient for some applications, but not particularly convenient for other applications. So what are other ways we can write the scale factor? I'm just going to move this word down a little. We could write the scale factor as a fraction. And so we could just say, well, 8 centimeters over 480 centimeters. The centimeters cancels out, and you just get a fraction, 8 over 480. Now, a scale is essentially the same thing as a scale factor, but you write this as a ratio. So when we write this as a ratio, we write it as 8 to 480. But there's a much more common way to write scales, and that is with the first number being a 1. So how do you go from 8 to 480 to a scale that starts with 1? All you have to do is ask yourself, what are you doing to the first number to get to 1? In this case, you're dividing by 8. So if you divide 480 by 8, you get 60. And you can see that is actually the same as the fraction in reduced form. If you reduce 8 over 480, you get 1 over 60. There's one other way to write a scale factor, and that is as a percentage. You'll see that quite commonly, especially when you're using a photocopier. So you can turn this decimal number, 0.016, repeating into a percent just by multiplying that number by 100 and adding a percent symbol. So if I multiply it by 100, which is the same as moving the decimal place over 2 spaces to the right, I get 1.6 repeating percent. So if I had an image and I put it on a photocopier, or sorry, if I had a picture of something, I put it on a photocopier, and then I punched in 1.6%, I'm obviously going to get a much, much smaller image, and that would be a reduction, which is similar to this, the only difference being I can't put the car itself on the photocopier. Now, why is this scale used so commonly, 1 to 60? Well, it's a very, very useful way to think about scale diagrams, because you can interpret this to mean that 1 unit measured on the diagram corresponds to 60 units in real life. So for instance, let's say we measure the wheel, and we determine that it's 1 centimeter. So that length right there, let's say, is 1 centimeter. Well, that means that in real life, the wheel is 60 centimeters. So we can say, all right, 1 centimeter corresponds to 60 centimeters. Or if we have the diagonal of the windshield being 2.5 centimeters, all we have to do to determine the length in real life is say, well, the image to the object is 2.5 centimeters to 60 times 2.5 centimeters. And 60 times 2.5 centimeters is 150 centimeters. So the actual object, the car's window screen, the diagonal would be 150 centimeters. So this equation right here can be used to answer a lot of problems. And quite often, you're trying to find a length in real life, but you're given a scale factor and a length of an image, or an image that you can measure. Or you're trying to find the length on an image, and you're given the length in real life and a scale factor. Or, as in this case, you're trying to find the scale factor, and you know a length in real life and you know a length in an image. So if you're given 2 out of 3 of these, you can set up an equation and use that to solve the equation.